The title is A Natural Balance, Defense of Asian Honeybees Against Predators and Parasites. And the differentiation between wild and Phero comes from, I don't know if you heard the talk of Jamie Ellis this morning, and he said it's very important to distinguish between these two, because the wild, they are never managed by human or by beekeepers, and the wild ones, they really still live in the wild. And we don't have many opportunities here in Europe to work with wild bees, and so we concentrate on Asian honeybees because they still are living really in the wild, and normally people who are called also maybe beekeepers or more bee hunters, they don't keep them, they hunt for honey. And so these are natural, still a natural balance, especially in Borneo where we work for a long time. No Apis mellifera was introduced, so we still have there a very natural situation. So I think this was enough for. Yeah, you see here many, Varroa was mentioned already, but there are many, many more predators and parasites for the honeybees. And still, because when they are not managed, they have to deal by themselves, and they found a balance. This shall be the balance. They found a balance between surviving of the bees and surviving of the predators and parasites. You all have seen this honeybee sting, the pillar of defense. And this really is, if you live in a society where you collect honey and you have brood and everything, you really need to defend yourself. And this is a sting, and this is a very sophisticated system. It is a very effective weapon, especially against men and other mammals. And why? You see here now again the sting which my husband, we are married for too long time and working together for more than 50 years, so you might see some of the same slides. So anyway, the sting remains in the skin, as you all know, and the bees fly off, and it is a sting autonomy. This is already prepared to do so, and what happens is, here you see the sting just starting going in, and after some time, the sting is really inside if you don't remove it. And this is how it works. The sting has many hooks. One of the lancets is inside with a hook, and then the other one is moving. And like this, it's pushing into the skin. And to show it more clearly, you see the lancets with the horns or the hooks. This one here is the shaft, and here you see the lancets, and this here is the shaft, and here you see that this is anchored. The lancets are anchored here, and so this is stabilizing, so it really can work like this into the skin. And of course, in the middle is the venom duct, and this gives you the pain and the swelling if you are not used to. And that is what's happening. The bee loses the sting but still can fly. And you are all beekeepers, you all know that often you have the sting here and the bee comes right back into your hair and tries to bite and even makes this horrible noise of stinging and even tries to bite you. And so humans know it, but animals will not know, so they really retreat and run. Because the sting is so important for defense, I just want to show you the evolutionary roots. Here you see the bush cricket, and this here is the sting which is used as ovipositor. And they use it to put the eggs into the ground so that it is well protected. The next step is that it is still an ovipositor. You see it very long here. But already there are some venom glands, and the larvae here will be immobilized, and so they cannot do anything against the egg and they will be eaten up. The next step is that the sting totally lost the function for egg laying, and this is paralyzed by the venom. This is the bee wolf, you all know this story, I think. And so in the end, we come up with a sting of the honeybee, which is only venom for defense. Yeah, this you have seen already, and now we start going to Asia. Here, these are the cavity-dwelling honeybees, and our honeybee mellifera belongs to them, but there are many more. The red bee of Sabah, Nuloensis from the mountains in Borneo, and this is the black bee. They call it the black bee in Sabah. And yeah, they all live in cavities either given by humans or normally in wild. Labyriosa, you have seen in the talk of my husband already, they build the nest underneath the large tree branches, and the dwarf honeybees, they build their nest around. And all these bees, they do have stings, so this is all function in the same way. But you all know, even if you have a very sophisticated defense, it is never 100%. And there are always creatures who develop some methods to overcome your defense behavior. So these are, how do they do it? We start with opportunistic predators. That means they also feed on other animals, not only on honeybees. So let's start with the cavity nesting. You have seen this also already. We are working together for too long. Main thing I wanted to, that they are all well protected in the cavity, from the cavity walls, and they only have to protect the nest entrance. And this is a Malaysian sun bear, and he likes to eat honey and bee brood, and you see that he's smelling that there must be something in here. Now he found, and actually there is a colony or combs of bees inside, and here he tries to starts to open it. You see he has really big claws, and he really can rip open even tough cavities. Anyway, when he's doing this, the bees, when there's a vibration, the bees inside, the Asian bees, they will make a hissing noise, like very loud, or I cannot really do it like bees are doing it. And when they hear the hissing sound, he will stop trying to come, and it's not that he's really scared of the bees, but this is kind of snake mimicry. You know, in cavities, not only bees are living, cavities give shelter for many bees, and for example, for snakes, and he has some bad experience with snakes, so he is retreating. But this hissing sound is not only for defense. Dr. Fuchs and Dr. Tautz from Germany and Dr. Sharma from India, they wanted to do experiments with Apis florea, especially dancing behavior. And when they were still far away, the bees were nicely dancing and doing everything. And when they came nearer, suddenly flight activity stopped, dancing stopped, everything stopped. And they, when they came nearer very slowly, they heard some noise, and so they put a microphone on it to hear it really. So he found these, I try now that you can hear the sound. So that's what the bees are doing. So in this case, it's not a real defense. There's a small communication. There's an enemy, and please hide away. My husband already told about that the method when you are small, you better hide. And so if you fly, you can be detected. But if you don't fly, if you don't move, detection is not so easy. Okay. So this is again, it's not only the noise that they communicate, there is the lamb pheromone for communication. Again, if you have only an entrance, only few bees, the guard bees, will see what's happening outside. And these bees are well protected, and they don't realize if there's an enemy coming. And for this purpose, the guard bee produce a alarm pheromone. This was discovered with Apis mellifera first, but then we tested it with the Asian honeybees, if this is typical for honeybees. And yeah, this is isopentyl acetate. This is the main alarm pheromone. And we took this, and we had these thumb tags with a filter paper, and on this one we had put alarm pheromone, and on this one not. And they start running, and at the end they start stinging. We did the same with Apis andreniformis. Yes, we have seen this. So we, because they are on the small branch, we hang it here, and here we have a platform where we offered the thumb tags with the alarm pheromone. And so you see, the bees start stinging there with alarm pheromone. And then we wanted to do the same test with Apis dorsata, and they are really defensive, and the problem is not that there will come one bee, they come with thousands. They really have huge colonies. So, and another thing is you see the chains here, and these, if there's danger, these up here, they just detach, and then the whole bees fall down. So it's not so nice to get stung. One bee, okay, but not so many. And so we constructed a cage, not for the bees, but for the observer. And you see how the observer is inside. And then we transported the cage into the jungle to the colonies. And that's, yeah, this is the cage. Now you can't see the observer. And here's the colony, and we could do the experiment. And it was very interesting. Of course, we not only had the alarm, we compared the alarm pheromones from all the species. So we collected the stings and we analyzed it. Ah, yeah, this is, there you see how they attack. We analyzed it, and here you see Apis mellifera, our bee, and the Apis cerana, you often call it the Indian bee. Anyway, it's the Asian most common and widespread honeybee in Southeast Asia. And you see this looks very similar. But Apis dorsata has another peak here at this point, and this is 2-decennyl acetate. And this is the molecule, and this is quite short, only 1, 2, 3, 4, 5, 6 Cs. And the other one is a much bigger one. So this means this one is very volatile. And you all know when you are marked by a sting, you better wash your hand or do something, because otherwise bees will attack you. And this one here is not so volatile, and it stays with your cloth for up to 24 hours. And here you see how a suit, actually this was your hat, looks like, with many stings. And the defending bees follow you really for kilometers. So you are marked, and you can walk. I remember once that we were running 5 kilometers something. Happily, it was near a village with experienced villagers, and they had hay of rays, and they would lit the hay, and we were staying there. And then when it burned down, we went to the next hay, and they lit it again. Anyway, so, and another problem is bees from other colonies join it. And here I must tell another story, because we worked with Apis dorsata colonies in the evening, and in our suits were quite a lot of stings. And so in the next morning, I wanted to put our bee suits into the sun so that everything will evaporate after some time. And while I was doing it on the bush, there were first 2 or 3 Apis dorsata bees, then suddenly there were 10, and then there were more than 20. So I just left everything and went into the entrance hall of the hotel or the rest house. And they even followed me into the entrance hall. And then they left me and they went to the windows. And then I called the hotel manager and said, "I'm sorry, but you have to do something with the bees here. And I don't know why they came." And he started laughing and took me around the house. And at the back side of the house, there were 3 Apis dorsata colonies. And they were smelling still our bee suits from the evening before. And they were still attacking or defending one should say defending, but in this case I had the feeling they were attacking because I was not near the colonies at all. Anyway, but even with such a nice alarm pheromone, you can find astonishing things. So you see the bee eaters, and here is one bee eater who has a bee in his beak. And you would say it's not so easy for the bee eaters to catch bees because they fly very fast and they always fly near the vegetation. They really behave differently to our bees. Even the small bees, they fly very fast. Anyway, what did this guy do? He would wipe the abdomen of the bee here on the branch very near to the colony. And what happened, unfortunately, we had no camera with us. What happened, the bees from the colonies smelled the alarm pheromone, and they would come here where he was wiping the abdomen. And he just hopped half a meter, not even half a meter to the side, and then he would eat one bee after the other, because they were all circling around here and not leaving, and also not flying very fast, but just looking for the enemy. And he would, I think he ate more than 10 before he finally left. So this is how other bees can exploit even the best defense of honeybees. So I just want you to demonstrate, you have seen this, at least the ones who heard the talk of my husband, the evolutionary trees. We think that since most bee species or wild bee species are living in the cavity, that this is the original one, and from the middle size cavity bees, one branch would go to the dwarf honeybees, and the other would develop into the giant honeybees, because its branches are enough there in the jungle, but cavities are interesting for many, many other species, for stingless bees, for snakes, for just a lot of ants. So anyway, and the loss of the protective cavity walls increases the predatory pressure. And so the open nesting bees had two alternatives. One would be to be very huge, and the other really small. And as I said already, yeah, and this is also true for the stings. So the giant honeybee stings, the normal bee suit is not enough, so they really come through. And so one thing is the dwarf honeybees, they hide, and you have difficulties to find, and whoever was traveled in Sri Lanka or in these countries, and are interested in bees, they might have seen these bee trees with the colonies here. They are exposed, enlarged, and here it is even better to see. Yeah. So, but how to deal with such a defensive Apis dorsata colony? So there still are. This is the oriental honey buzzard, and he likes actually to eat the brood and the honey. And they are well adapted to this. If you compare our buzzard with the honey buzzard, you see that the feathers of the honey buzzard are are very short and hard and not really feathers anymore. And here you see the feathers long and soft. So the bees cannot really hurt him. But so the bees had to develop a method to deal with it. So when the buzzard comes, you see he would grab here the comb and fly away. But what the bees are doing when they see a buzzard coming, they build long chains. You can see here is a comb. I hope you can see it. And here are the bee chains. So when the buzzard comes and tries to catch the end of the comb, he will only grab into the bees and will not get a comb. But we thought that's what we saw. And actually, you better run then because there are a lot of bees in the air. But we heard a story from a colleague from ours that there were two. So one was grabbing into the bee chains only, and then the next one could see the comb and would grab the comb and fly away. So there are always very astonishing things. So that's what I call trick and treat. Another dominant predator is the weaver ant. And you all know weaver ants, they live in the trees and they spin the leaves together, and they have, to do this, they have very strong mandibles here. And here they have found a Serrana bee, and you see how they all pull and they just tear it auseinander, apart. They tear it apart. And when you're a small bee like Androliniformis, you have about the same size as the ant. And so this really, there is no match. You cannot fight. They cannot fight. So they had to develop a trick. And maybe you see here that this is shiny. They construct here sticky rings. And as soon as they really do maintain here the sticky ring, and if you put what we did, an ant on the colony, many of the bees go and maintain or fix the ring very, very soon and very effective. And that's what we also saw when an ant comes. It will not cross a sticky ring. It's a barrier. And it's really funny to watch them because there seems to be also something inside which is tickling, or I don't know. Anyway, they start to keep one leg like this and the other one, and then they go. So this is again a trick. Yeah. And this is also a very common predator here. These are huge wasps. And the problem is that the sting cannot penetrate to the chitinous exoskeleton. And if you have the European bees, they try to do that. But what are the Serrana doing? They cling together and they start balling these bees. And you even can take it away. And when you put it on your hand, it's really hot. So I saw it first time in Japan with Apis cerana, and that was a real one. And we really had to put it the ball from one hand to the other because it was hurting. Anyway, what they do, they cook the wasp to death, and even if some of the bees in the middle will also die, it's nothing compared to the situation when such a wasp will alarm their nest and tell that there can be a honeybee colony robbed. Yeah, that's just not such a big enemy, but it's a nice big spider, and they like to nest near the colonies. And I hope you can recognize here, this one has caught a drone and eating it up. So this is also a predator. But now we come to the parasites. We were working near the Apis dorsata colonies in the night, and we heard a noise, which showed us that the bees were disturbed. And then we took a torch, and there we saw that there's a honey sieve. Then next evening we came there again, and of course then we had our camera, or Nico had his camera, better saying, his camera with him. And there we saw it entering, coming near, and obviously it's so well adapted, it knows that actually the honey portion of the colony is always, the dorsata like to have, to nest at trees where schräge. Anyway, so at the upper part there's always the honey, and obviously the honey sieve knows where to go. And here now you see the disturbed bees, and that's what we heard. And here it has dived into the bee colony, and you can follow where it's, here all the bees are hanging in a very straight order, and here you always see where it is disturbed. And there you can see how it came out again. And this was Acherontia. We tried to catch it. It took some time because it was high up until we succeeded to catch such a moth. And in Sri Lanka, we saw another species of the dead head. It's called dead head hawk moth because it has a dead head here, and here it's even more pronounced. It has another species, and in Africa we do have these dead head hawk moths as well, and they, from time to time, they come over the Alps. And I don't know if you have got them here in England, but in any case, we have them sometimes in Germany. Yeah, and this is a very long story. That really is you may think it still looks pretty, but it really is a very ugly parasite. Actually, we didn't know that. We had seen this fly, but we didn't know what it is. And our colleagues where we work in the bee station, they called us and showed us that there are crawling bees on the ground in front of the colonies, and we should have a look what it is. And what we saw are that there were two stigma showing out, and so we already thought this might be a parasitic fly. And we dissected and found these larvae. And at the end, when it comes to pupation, it's really, really big. Of course, we had a student who did all these preparation and drawings, and it starts with a very small larvae, and at the end, it fills out all the abdomen. And here you see a proboscis. If the abdomen is eaten up, then they can enter the thorax and they will eat the flight muscles. And then that's the stage where we find the crawling bees in front of the colonies. And of course, we did an experiment how often bee colonies are infested. And we put the bee trap here. And so if they have a dead bee to carry out, they cannot fly high, and so they come here and they will leave the dead bee here. So you can, that's a Gary bee trap, I think you may know it. We only changed it a little bit. And then we could collect all the dead bees. And our colleagues, Salim Tingek and Herbert Lim, they found that there is a seasonality in the distribution of Physocephala, of this fly. We then started to collect dead bees also at Apis dorsata, at the giant honeybees, and at the we then kept them in, so I didn't say, so they are with dorsata, with the giant honeybees, and also with the cavity nesting bees. And after 14 days, we kept them in a jar and wanted to see what will come out at the end. And this was a very difficult task. Somehow we came up to this stage, and then they were gone. We didn't know what happened. And then we put them on our, we took them from the lab to our house and put them on our table so that we could see them all the time. And then we saw some ants crawling around. And then we removed, put new water in under the table to hinder the ants to come. We thought the ants had eaten them. And then in the end, we realized when we looked closer, this is not an ant, as you can see, but it looks like an ant. And they really do climb up, and they still look red and no wings. And the explanation is the bees, when they are dead and it takes 2 weeks and there's rain and leaves coming down, that they are underneath some gravel. And if you pupate and have wings and then you have to dig through the leaves, it will hurt your wings. And so they went up, and only then a secondary metamorphosis, we didn't know that before, started. And at the end, after 3 hours, our fly looked like that. And actually, we sent it here to the Natural History Museum, and they identified these bees as Physocephala paralleleventris. And this was already described 1910, I think. But they didn't know where the larvae lived. So this was somehow a new discovery. Yeah, and so there starts a new generation of Physocephala. And as I told you before, dorsata bees are much bigger, and you see here the difference in size. And we are not yet sure if these are just because they got more to eat or if they are different species. Yeah, so, and the females, these are the females and these are the males. The females are always bigger. And when you know the fly, you can see them, of course, perching near the colonies, and they attack the bees, the flying bees. They dive down, and because if the bee sits, the abdomen is covered by the wings, so they need to get the flying ones, and they have to put the egg on the right place. And for this, they have a special segment here. Yeah, you can see this, and I'll do so. They have a lot of hairs, and this escape to grab the bees for a short time. And then here they have the spine to pierce the intersegmental membrane to put the eggs in. And it is still not known, because we always worked on places where there was no mellifera introduced. It is still not known if it can also reproduce in Apis mellifera, because we know it for 3 species, for Dorsata, for the giant bee, for the red honeybee, and the black honeybee in Borneo. So who knows what can happen? Yeah, and now what about the honeybee mites? The Asian honeybee mites, first we only heard about, actually here in Europe, we heard about the Varroa jacobsoni when it came here. And not many people knew anything about honeybee mites. So then researchers started looking for them, and this was the knowledge from 2004. So there were 2 species of Tropilelaps, which lives on the parasites on the giant honeybee. Here we found then at the end 3 varroas, Jacobsoni, then Rinderi underwoodii, and Uvarroa we knew from, we found in, or was already described on the dwarf honeybee. So every bee has somehow his own bee mite, but that's only looking at these here at the Tropilelaps, how it looks nowadays. I just don't want to go in, but now we have 4 species, recognized species of Tropilelaps. We have 4 species of Varroa, and the only one which is switched over to mellifera is this one, not Jacobsoni as we thought before. And this is the Uvarroa with the dwarf honeybees. Since where we worked, we had all the bees, and we saw also robbing bees. You see here colonies of Apis dorsata. Here's another colony, and we put trays underneath, and the trays were again in the stands were put into water, so that no ants, oil, so that no ants could collect the debris which came down. And just we collected for 3 weeks, and just to show you so we found, that's what we expected, Tropilelaps clarae and Königerum. But we also found Jacobsoni, Rindereri, and Uvarroa wongsiri, which comes from Apis endriniformis, the dwarf honeybee, which is in Borneo. We also found numerous heads from these weaver ants and other ants too. And these giant honeybees, they can bite them. They are big enough, and they are no match for the ants. We found 2 geckos, and actually only 1 dead-head hawk moth, though we have seen even after we caught 2 or 3 dead-head hawk moths. And the next evening there were again plenty. So it really is a pest. But they only eat honey, so maybe that's why the dorsata did not develop anything special against this, because some honey is not so important. And then, of course, we checked many brood cells if any of these mites could reproduce in the brood cells of Apis dorsata. Because we had already, in several meetings, was told that you could find mites in the debris of different species. But at least we did not find any reproductive stages of any other mite besides of Tropilelaps. So this is really a special thing. Yeah, but how does the bee handle with a mite which is specialized on this bee species? This is one thing you see here. Actually, you can see this bee is even shaking a little bit and going to other bees and telling the bee, you must clean me from, I've got a varroa, please take it off. I can't. So this is what was called grooming behavior. And they also are able to bite then the mites. And dorsata also can kill the Tropilelaps mite. The next thing which I think is more important is varroa only can reproduce in drone brood. And drone brood, one thing is if a colony has few more drones or less drones, does not kill a colony. And the other thing is that the bees can recognize if a mite is reproducing in a worker cell, and they will destroy the worker cell. But normally, even if a mite comes, we have found several mites in worker brood, but we never found reproductive stages. But if they reproduce, they can open the cell and remove it. And the second thing is, yeah, I hope you like these nice drone brood with an opening at the top. And if there are too many varroa mites inside and the larvae will die, they don't open. They just leave it like it is, and then the larvae is dead and all the mites are dead as well. We call this entombing the varroa mites. Yeah, so the drone cells, if there are too many inside, it's a deadly confinement. So what I told you now is if you look to the Asian honeybees and you look to the Asian bee mites, they start to, or they can live, but the bees have many modes to keep them under a level where they really will damage the colony. So they only can reproduce in drone brood. If there are too many, they entomb the mites in the drone brood. They have this grooming, and they remove the varroa from the mite. And if all this does not help, they simply leave the brood behind and swarm. Or actually, they just leave the hive. So, but you all know this. Our Western mellifera, they cannot deal. The mites can reproduce and do reproduce a lot on worker brood. And if it's only one mite, the bee still looks quite normal. But I think this is a bee with maybe 5 mother mites and And already Jamie told you this morning also the viruses which are coming with a. So at the end, our western honeybee, many of the colonies will die. And so this is quite different to what we have experienced with the Asian honeybees. If there's not a beekeeper who is helping their bees and fighting against the mites, they will kill the colonies after 2 or 3 years. And so since you all have your own method, what you will do against the mites, I don't want to tell you what is the best. Nobody knows. If one would know what is really good, we would not have such a big problem. So, and this is the end of the talk. So the predators and parasites and the natural defense of Asian honeybees, so they keep it in balance. And we now want, that's where we worked a lot. This is the bee station in Tenom, in Sabah, Malaysia, on Borneo. And we, of course, did research, but at the same time, it was adventure, and we liked climbing and doing all these things. And we experienced the harmony between the different Asian honeybee species and the balance between parasites and predators, and the harmony within the people who were hosting us and helping us and showing us a lot of things, yeah, which is called the Asian hospitality. And we really have to thank all our friends in Pakistan, Sri Lanka, Thailand, Malaysia, Vietnam, Philippines, and in China, where I didn't tell you every time where we have done these experiments. And of course, also many thanks to our sponsor, ApiTrade, without whom we would not be here and you couldn't have heard this talk. And finally, many thanks to all of you for your kind attention. Thank you very much.
The research you described on the alarm pheromone, do you know any results from African bees? Defensive African bees, do they have similar alarm pheromones?
Yes. Actually, the mellifera alarm pheromone is about the same. It's only the direction of the bees is different. Actually, we were breeding bees not to be so defensive. And if you still have to handle with wild animals like the honey badger and so on, you must be very defensive. And so I remember one colleague of us, he did experiments, I think in South America, to demonstrate the alarm pheromone, and he had a device for the experiment, and he came back to our institute and wanted to do the same, and he didn't get any reaction, and we had all the students around and nothing happened. So it's not only just the pheromone, it's just also how bees react to it.